It's amazing, isn't it? We just slip these smartphones into our pockets like it's nothing.
And they're basically, what, little supercomputers.
Right. You think about it, that's incredible. But we kind of forget sometimes just how incredible that is.
It's true. All this miniaturization, we're so used to it now.
Exactly. But imagine, okay, a world where um, a wireless receiver, fits on your finger like
Yep.
a ring.
Like a ring, wireless. What would they even do with that?
I know. Wild. Right. That's where we're diving in today. To the early 1920s, we're going to use a 1922 handbook for radio amateurs.
Oh, wow.
It's basically a DIY guide for building your own wireless sets.
Wow, so this is like really early days of wireless.
Absolutely. And the things they were doing back then are pretty amazing. Like they were receiving messages, get this, hundreds of miles away.
No way. Hundreds of miles with the tech they had back then.
Yeah. They were using vacuum tubes
Yeah.
for detectors and amplifiers, which we'll read about.
Wow. It's really impressive.
I know, right? Yeah. And it wasn't just like, hobbyists in their basements.
I'm right. Yeah.
The government was already using this new tech.
Oh, really?
Yeah, broadcasting weather reports, crop updates, even time signals.
That's interesting. Really shows how quickly this stuff started being used, right, for real world problems.
For sure.
Yeah.
And you want to talk about innovation. This handbook, it reveals this craze that was going on.
Like cray.
Making wireless as small as they could. Amateurs were competing, building the smallest, most unusual sets.
Really? Like what?
Suitcase sets. They had a set built into a Brownie camera.
No way.
And, yep, even that wireless ring with an umbrella as the ground.
A ring and an umbrella. I have to hear more about that. What was driving this miniaturization? Was it just for fun? Or was there some practical use they had in mind?
That's a great question. I'm curious about that, too. Maybe the handbook gives us some clues.
Mm-hmm.
But it wasn't all about just, pushing the boundaries of size.
Yeah.
This handbook was also about helping beginners,
Mm-hmm.
helping them, navigate this whole new world of wireless.
Makes sense.
Like it gave advice on how to choose good equipment, avoid all the junk that was out there.
So like a buyer's guide, kind of?
Exactly.
Yeah.
It even had it had a list of manufacturers and suppliers.
Interesting. I wonder what companies were big back then. Are any of them still around?
We'll have to see. And they didn't forget about safety either. There were these warnings about fire underwriter requirements
Oh.
for lightning switches.
Oh. To protect against lightning strikes, I guess?
Yep, you got it. Okay, now here's where it gets really interesting. This handbook actually gave people instructions
Ew.
on how to build their own simple telegraph and telephone sets
Wow, really? Like from scratch?
from scratch. It covered, well, everything.
Yeah.
Aerial construction using, copper or aluminum wire, insulators, lightning protection,
Yeah, all the essentials.
to the types of transmitters like
Yeah.
spark gap and vacuum tube transmitters, and then on to all the different kinds of receivers using crystal detectors, tuning coils, and headphones.
It's amazing.
I know. And then there's a whole chapter on just explaining electricity, the basics like current, voltage, resistance. They used analogies, like water flow.
Oh, to help people visualize it, I bet.
Yeah, exactly.
Smart. Did they go beyond the basics? Did they ever cover anything more complex?
Oh, yeah, absolutely. They get into things like electromagnetic induction, high-frequency currents, and the relationship between capacitance, inductance, and wavelength.
Wow, so this wasn't just some basic how-to manual.
Definitely not.
That's impressive. I can't wait to see what they had to say about vacuum tubes. Those were revolutionary.
Well, get ready, because it's all in here. They go into detail about how those amazing devices actually worked,
That's awesome.
starting with the simple 2-electrode tubes, and then progressing to the game changer, the 3-electrode tube.
3-electrode tubes, that's where things really took off, didn't they? For amplification and signal control.
Yeah. And the way they explain it, the way they break down the function of each part, the filament, the grid, the plate, and how they all work together to detect and amplify signals.
It must seem so cutting edge back then.
It was. They were even talking about the importance of things like filament heat, plate voltage, and the vacuum level, all for optimal tube performance.
Fascinating. And I'm guessing they didn't stop at just one type of receiver.
You know it. They describe all sorts of receivers, from simple crystal detector sets to vacuum tube detector sets and even regenerative sets.
It's amazing how fast that technology was evolving.
I know, right? And, we can't forget about those really advanced topics they covered. I mean, stuff that must seem like science fiction back then.
Oh, I agree. What were some of those cutting edge concepts?
Well, they talked about heterodyne reception, for example. for those long-wave telegraph signals they used for transatlantic communication. And then there's the use of loudspeakers, which were just starting to come out as a way to, let larger groups hear wireless signals.
It's amazing to think how those early ideas led to like the whole mass media revolution.
Right. And they also give advice on how to deal with things like static interference and signal distortion.
Practical stuff.
Very practical, which just shows how much these early enthusiasts were really problem solvers.
They were pioneers, really, figuring out how to make this technology work.
Absolutely. And that's just the beginning. In part 2 of this deep dive, we're going to explore how this 1922 handbook explained these complex ideas to people who weren't already scientists and engineers.
I'm ready. Let's do it. It really is amazing to think about, like how all this basic electrical stuff, it was brand new to them.
Totally. And I was looking at the instructions for actually building those wireless sets.
Right, right.
And you pointed out some great examples of how DIY this whole thing was.
Oh, yeah. For instance, for tuning a transmitter,
Okay.
they actually recommended using a hot wire ammeter.
A hot wire, what is that?
Well, it's basically, it was a way to measure those high-frequency currents they were using back then.
Okay.
The current, it'd go through this thin wire and heat it up.
Okay.
And the wire expands, the hotter it gets, the stronger the current. So it gave them a visual way to see how well they had tuned their transmitter.
So it was like a thermometer
Yeah, exactly.
for their wireless set.
For their wireless set, yeah.
That's so cool.
Yeah.
What else did you find?
Well, remember those crystal detectors we were talking about?
Oh, yeah.
The handbook has these really specific instructions for adjusting that little contact wire, that cat whisker,
Oh, yeah.
to get the best reception.
I can just picture these guys huddled around their sets,
I know.
fiddling with that tiny little wire.
Right. Just trying to get that sweet spot, that clear signal. It's amazing. And even when it came to like the actual tuning, the handbook had tables that correlated things like the condenser's capacitance and the coil's inductance to specific wavelengths. So they could tune their sets to receive, particular frequencies.
So finding the right frequency. Some things never change.
Right. It's all about finding that sweet spot, isn't it?
Yeah.
And that's a great way to kind of connect back to the big picture, because while the technology itself has obviously come a long, long way, the underlying principles are still the same. We're still dealing with, electromagnetic waves, tuning circuits, the challenges of amplifying weak signals.
So in a way, this handbook, it's like a window into the DNA of modern wireless.
Exactly. And speaking of DNA, let's dive into the heart of these early sets.
Okay.
Vacuum tubes. I mean, the handbook really gets into detail about how they work, right?
It does. It breaks down the function of each part. And, you mentioned those 3 electrodes earlier.
Oh, yeah.
The filament, the grid, and the plate.
Yes, and it's so crucial to understand how those components all interacted. So the filament, when it's heated, right, it would release a stream of electrons.
Okay.
And the plate, because it was positively charged, would attract those electrons, creating this flow of current.
Got it.
But here's where things get really interesting.
Okay.
The grid.
The grid, yeah. Tell me about the grid.
The grid. It was it was positioned between the filament and the plate, like a gatekeeper.
Okay.
And it would control the flow of electrons.
I think.
By applying even a small voltage to that grid, you could drastically change the current flowing between the filament and the plate.
So like a super sensitive control knob.
Yeah.
Right, for the signal.
Exactly. And that ability to control the current with just a small voltage change, that was the foundation of amplification.
Which is still a key concept in electronics today, right?
It is. It's amazing how much of our modern world rests on this tiny little device. And, this handbook was written at a time when those vacuum tubes were still fairly new.
Right.
And rapidly evolving.
So cutting edge.
Yeah. And it actually the book details the progression from those simple 2-electrode tubes, which could only detect signals, to the revolutionary 3-electrode tubes, which could both detect and amplify.
They must have felt like they were watching like the birth of a whole new technology.
They were. And the handbook really captures that excitement. It even mentions how those early gas-filled tubes, which weren't truly vacuums like we think of them now, they were actually more sensitive detectors than the fully evacuated ones.
So interesting. All those early variations, right?
It shows you how much experimentation and innovation was happening. They were always pushing the boundaries.
Always pushing, yeah. And this handbook captured it all.
Mm-hmm.
More than just a technical guide. It was really like an invitation to join this whole revolution that was changing the way we communicate.
Exactly. This wasn't just for experts, it was for anyone who was curious and wanted to be a part of it. It gave them the knowledge, the skills, the inspiration to build their own sets and experience the magic of wireless.
Okay, so now I'm curious. All this talk about vacuum tubes.
Yeah.
What about the sound quality? Was it anything close to what we're used to today?
That's a great question. And it actually leads us perfectly into the next part of our deep dive,
Okay.
headphones and loudspeakers. Because the handbook actually dedicates a whole section to those, showing how, those early wireless signals were translated into something you could actually hear.
Okay, I'm all ears.
So back then, the most common way to listen was through headphones. But we're not talking about your everyday earbuds.
Right.
These were specially designed headphones for wireless reception. They had higher resistance and more sensitive diaphragms compared to, like, standard telephone receivers.
So these were serious headphones, huh?
Oh, yeah. Fine-tuned instruments for those faint signals.
Wow.
And the handbook actually explains that the sensitivity of the headphones depended on the number of turns of wire on the electromagnets inside them. More turns meant a stronger magnetic field, which vibrated that diaphragm more effectively and gave you louder sound.
So cram as much wire in there as possible.
Yeah, basically.
Makes sense.
And to get more turns, they used thinner wire, which increased the resistance.
Okay.
So when they talked about a headphone's resistance, like 1,000 ohms or 3,000 ohms, that was basically a measure of how sensitive it was.
So higher resistance, better reception.
Yeah, generally speaking. And there's actually this fun fact that the handbook mentions. If you had an old telephone receiver lying around, you could rewind it with thinner wire to make it more sensitive for wireless use.
It's like ultimate DIY.
I know, right? Okay, but what about loudspeakers? Were those even a thing back then?
That's what I'm wondering, yeah.
Oh, they were. And the handbook describes them as essentially like a combination of a telephone receiver and a megaphone.
Okay. A simple way to make it louder, I guess.
Exactly. So the vibrations of the telephone receiver's diaphragm, they get channeled into that horn-shaped megaphone, projecting the sound outward, more volume. It's interesting. They even recognized back then that using two headphones and a loudspeaker setup could give you like a richer, more balanced sound than just using a single one.
Ooh, so like a precursor to stereo.
Right. And the handbook actually highlights a few different loudspeaker designs that were being used. Some with those simple horns, others using more elaborate mechanisms to really amplify those vibrations and improve the sound quality.
So they were already thinking about how to make the listening experience better.
Oh, yeah.
Interesting.
Absolutely. And all those innovations in headphones and loudspeakers, they were really driven by that desire to share the magic of wireless with more people.
Because, yeah, huddling around a single pair of headphones could only be fun for so long.
Exactly. The development of those loudspeakers really paved the way for, wireless broadcasts to be enjoyed by larger groups and ultimately for things like the mass media revolution that would come later.
So how did they even begin to explain the science behind all of this?
Right.
To people who weren't already experts. How did this handbook break it all down?
Well, that's where things get really interesting.
Right.
The handbook didn't just talk about, like, building sets.
Yeah.
It actually dove into the fundamental principles of electricity and magnetism. It has this whole chapter dedicated to explaining these concepts to beginners.
So it wasn't just about, like, building it, but understanding the forces that made it work.
Exactly. They wanted people to understand the science behind it. And to do that, they used this really clever technique.
What's that?
Analogies. They compared the flow of electrons in a wire to something everyone understands, the flow of water in a pipe.
Oh, yeah, that makes sense. Makes it easier to picture.
Right. So current, for instance, measured in amperes, was like the amount of water flowing through the pipe. Voltage, measured in volts, was like the water pressure pushing that flow. And resistance, measured in ohms, was like the friction inside the pipe slowing the flow down.
So you could, like, literally picture the water moving through the pipe.
Exactly. And that helped you understand how those tiny electrons were moving through a circuit.
It's like a universal teaching tool. I remember using those same kinds of analogies in my science classes.
Right. It works. And they used it for even more complex stuff, too, like capacitance, the ability of a condenser to store electrical charge.
Okay.
They compared that to, like, a tank holding water.
Oh, I see.
So the bigger the tank, the more water it can hold. And just like that, a larger condenser can store more electrical charge.
Clever.
It is. It's like they were bridging the gap between the physical world and those more abstract electrical concepts.
Yeah.
It made it much less intimidating for people who were new to all of this. And it empowered them to not just build their own sets, but to actually understand the science behind it.
That's amazing.
Yeah.
But wireless technology, it goes beyond just simple circuits.
Right.
It's about like sending signals through the air.
Right.
How do they explain that?
Well, that's where the handbook takes us even deeper into the wonders of science.
Oh, okay.
They didn't stop with those basic electrical concepts.
Yeah.
They went right into electromagnetic waves, those invisible carriers of wireless signals.
The real magic.
Yeah.
I bet that was a challenge to explain back then.
It was.
Yeah.
But they actually did an amazing job building upon those water analogies they had established.
Okay, but how do you connect water, something we can see and touch,
Yeah.
with, an electromagnetic wave?
Well, they drew these parallels between, like, the ripples created by a stone dropped in a pond
Okay.
and the way electromagnetic waves radiate outward from a transmitting antenna.
I see.
So those ripples, right, they spread out in those concentric circles,
Yeah.
carrying energy through the water.
Yeah.
And just like that, electromagnetic waves carry energy through space.
Got it.
And the handbook emphasized that just like water ripples have a certain wavelength, the distance between the crests, electromagnetic waves also have a characteristic wavelength, which determines their properties.
And that wavelength, that's what determines what we can receive, right?
Exactly. Different wavelengths for radio, television, Wi-Fi, all that stuff.
Right.
And the handbook stressed that tuning a wireless set is all about matching its circuitry to the specific wavelength of the signal you want to receive.
Kind of like tuning a musical instrument to a particular note.
Exactly. Finding that harmony between the receiver and the incoming waves.
Yeah.
And they gave practical advice on how to do that, how different components in a wireless set, like the condenser and the tuning coil, could be adjusted to select those specific wavelengths.
So it wasn't just about building the set. It was about fine-tuning it to become a receptor for this whole invisible world of wireless signals.
That's a great way to put it. And they even went beyond the basics, touching on more advanced concepts like modulation, which is the process of imprinting information onto those carrier waves.
Right, because a wave without information, it's just a wave.
Exactly.
We need to put our voices, our music, our data, all of that onto those waves to make them meaningful.
Exactly. And the handbook explained how different modulation techniques could be used to achieve that, really laying the groundwork for the development of radio broadcasting, telephony, all these wireless communication systems.
It's incredible to think how much of our modern world was already being imagined back then in that 1922 handbook.
I know, it's really remarkable. Those early pioneers, they weren't just building devices.
Yeah.
They were really building a foundation for a technological revolution that would change the world.
Mind-blowing.
Yeah.
So as we move into the final part of our deep dive, I think it's important to keep in mind all these connections, right?
Yeah.
Those seemingly simple circuits, the carefully adjusted cat whiskers, those explanations using water analogies, they were all part of a journey that led us to this hyper-connected world we live in today.
It's true.
A world where all these once impossible innovations have become, I don't know, almost invisible.
Right. We take it all for granted.
Yeah. Until, of course, we take a deep dive and rediscover the magic that made it all possible.
That's what we're doing here.
I can't wait to see what else we uncover in part 3. We've talked a lot about how innovative these early wireless guys were.
Yeah.
But I'm curious, what about the challenges? What kind of hurdles did they run into?
Oh, there were plenty. I mean, one of the biggest headaches back then was interference.
Interference.
Yeah, trying to pick up this weak signal from a station miles away, and then all you hear is static crashes and other noise.
Oh, man, I bet that was frustrating.
It was. And this 1922 handbook, it actually talks about that.
Really?
Yeah, they give it advice on how to minimize it.
Okay, so what do they recommend?
Well, for starters, they said, put your receiver as far away as possible from any electrical equipment.
Okay.
Anything that could cause sparks or disturbances.
Makes sense. Find a quiet spot, right?
Exactly. And they also recommended using shielding techniques, like enclosing those sensitive components in metal boxes.
Well, like to block out the electromagnetic field?
Right, like a Faraday cage, basically.
Clever.
And they were even experimenting with directional antennas.
Oh, wow.
Aiming them at the signal they wanted and away from the interference.
So like early satellite dishes.
Yeah, kind of. It's amazing how much those early solutions resemble the stuff we use today, isn't it?
It is.
But they were also, really dealing with limitations in their equipment, too.
Right.
Always trying to make those receivers more sensitive, more selective.
Yeah, you need that balance, right? Because a receiver that picks up everything is almost as bad as one that picks up nothing.
Exactly. And the handbook talks about some of those improvements, those advancements we touched on before, the switch from crystal detectors to those more powerful vacuum tubes, the development of better tuning circuits, all those things that led to the clarity and range we have today.
Yeah.
But even with those advances, there were still limitations, like long-wave telegraph signals, the ones they use for transatlantic communication.
Yeah.
Really hard to receive clearly.
So that's where those advanced techniques like heterodyne reception come in.
You got it. And the handbook actually explains it, the principle behind it, which is pretty amazing considering it's still used today.
Okay, so how does it work? I mean, just to refresh our memories.
Okay, imagine you have two tuning forks,
Okay.
and they're vibrating at slightly different frequencies.
Yeah.
When you strike them both, you hear this series of beats.
Oh, yeah, yeah. I remember that from physics.
That's caused by the interference between the two frequencies.
Okay.
Heterodyne reception, it's essentially the same idea, but with radio waves. You combine the incoming signal with another signal, one you generate locally.
Okay.
And that has a slightly different frequency.
Yeah.
So now you create those beats, but they're shifted down into a range we can actually hear.
So you're basically taking those super high frequency waves.
Right.
And converting them into something we can hear.
Exactly. It's really clever. And the handbook even talks about those early heterodyne receivers. Some used a separate oscillator to generate that local signal. Others, they actually use the detector tube itself
Wow.
to create those beats.
It's amazing how they figured all this out with such limited technology.
It's incredible, isn't it? They were so inventive,
Yeah.
always pushing the boundaries of what was possible and expanding the reach of wireless communication.
All documented in this incredible handbook.
I know.
It's amazing to think that, this seemingly simple book, it really captured this whole technological revolution.
It did. It gives us this amazing glimpse into a time when the world was being completely transformed by wireless.
Yeah.
And it reminds us that even the most complicated technology, it's all built on these fundamental principles. And anyone can understand them if they're curious enough.
Absolutely. And going back and revisiting these early days, it gives you this whole new appreciation for the amazing journey that led us to this world we live in today. This hyper-connected world.
I know, right? It's everywhere we look now.
We're surrounded by it.
Yeah.
And it's easy to forget how we even got here.
So true.
So next time you're, using your smartphone or
Yeah.
streaming a movie,
Or just, enjoying anything wireless.
take a minute.
Yeah.
Think about those early pioneers
Yeah.
who dreamed of this world connected by invisible waves.
Their legacy is everywhere, isn't it? In every bit and byte traveling through the air.
It really is. Well, on that note, I think we've reached the end of our deep dive into the fascinating world of early wireless.
It's been a great journey.
It has. Until next time, keep exploring, keep asking questions, and never stop being amazed by the wonders of our technological world.